Chapter 8, Lesson 3. I'm going to do 4 or 5 practice problems with you, just to help you out a little bit for those who might need some help. And for those who already got it, this is just going to be some reassurance. So I'm going to do, for this page, I'm going to do number 11, 12, 14, 15, 17, and 18. For number 11, they're asking me to find the sine of m, the cosine of m, and the tangent of m. My angle m is over here for number 11. When I look at everything in relation to angle m, if I look at number 7 is opposite. So I'm going to write O for opposite of m. Looking at 24, 24 is adjacent to m. So I'm going to put A for adjacent, and that's going to be 24. If you're ever wondering, well, which one is the adjacent? There's two sides touching angle m. The adjacent is always going to be the leg, and it's always going to be not the hypotenuse. So in this case, 25 is the largest side, 25 is opposite of the 90 degrees, so 25 is the hypotenuse. I'm going to write H for hypotenuse, and that's 25. If you ever wonder which one is the leg, remember that whatever the leg is, the adjacent leg, it's not going to be the hypotenuse. It's not going to be the largest side. So those are the 3 relationships to m. The opposite of m is 7, adjacent to m is 24, and the hypotenuse is 25. So when we talk about sine of m, we're talking about from SOHCAHTOA, S-O-H, or opposite over hypotenuse. So sine of m, knowing that my opposite is 7 and my hypotenuse is 25, my ratio, my trigonometric ratio would be 7 over 25. That is sine of m. When we talk about cosine of m, that's the c, right? And that's going to be adjacent over hypotenuse. Adjacent over hypotenuse. And what is adjacent to m? Adjacent to angle m is 24. It's touching it, and it's the leg. That is adjacent. And the hypotenuse in this case is going to always be 25. So the trigonometric ratio for cosine of m is going to be 24 over 25. And when we're talking about the tangent of m is going to be the TOA, or opposite over adjacent. So when we talk about tangent of m for number 11, the opposite side is 7 and the adjacent side is 24. So tangent, the trigonometric ratio, or tangent of m, is 7 over 24. So that's number 11. When we talk about number 12, here is our m now. So my angle is still m. My angle is m. Opposite of my angle m is 4 times the square root of 2. And again, I'm going to write O for opposite. The hypotenuse is always opposite of the 90 degree angle. This is the symbol for 90 degrees. So the hypotenuse is 9. And then the side that's adjacent to m is the leg that's always touching m. In this case, the adjacent side is 7. So for number 12, my angle will be m, my opposite side will be 4 root 2, my hypotenuse 9, and my adjacent side will be 7. When we talk about sine of m, in this case, remember sine, the so is opposite over hypotenuse. So when I look at number 12, sine of m is going to be 4 times the square root of 2 over the hypotenuse, which is 9. So sine of m is 4 root 2 over 9. When we talk about the cosine of m for number 12, that's the or opposite over hypotenuse. And in the case of that, the adjacent rather, I said opposite? Adjacent or hypotenuse, I apologize. The adjacent is going to be 7, and our hypotenuse is always going to be 9 in this case, so our trigonometric ratio or cosine of m will be 7 over 9. When we talk about the tangent of m in question number 12, tangent is the TOA or opposite over adjacent. In the case of this, tangent of m is going to be 4 times the square root of 2 over the adjacent, which is 7. So 4 root 2 over 7, that's my trigonometric ratio or for tangent of m. Number 14. If you look at number 14, remember these are all right triangles. We have an x over here. We have a 35 degrees over here, and then we have that 20. So everything looks like it's going to be in relation to that 35 degrees. So my initial angle is 35 degrees. If you look at x, you notice that x is opposite of 35. So I'm going to say that my opposite of that angle 35 is going to be x. And notice that the 20 is opposite of the 90-degree symbol. So I'm going to say that the hypotenuse, or h, is going to be 20. So we're looking for x. They give us 35. Notice that the x is opposite and the hypotenuse. So if we look at our SOHCAHTOA, the one that has opposite and hypotenuse is sine. So when I write this out, it's going to be sine of 35 degrees is equal to opposite over hypotenuse. So x over 20. So in order for me to find x, I'm going to multiply both sides by 20 because x is being divided by 20. I'm doing the opposite operation. So 20 times the sine of x is going to get, oops, my mistake. 20 times the sine of 35 is going to be equal to x. I multiplied 20 on both sides. Then you might want to grab your calculator. Make sure your calculator is set to degrees. And I get that x equals 11.5. And remember, the problem is asking you to round to the nearest tenth. So x is equal to 11.5. That's number 14. If we look at number 15, our angle is 41. So our angle is 41. If we look at stuff in relation to the angle, I have my 90-degree symbol. That 90-degree symbol has 11 across from it. So that tells me that 11 must be my hypotenuse, so h for hypotenuse. And then I have this x that's touching angle 41. And when we have a leg that touches the angle, that means that that is our adjacent side. So our adjacent is x, and that seems to be what we're looking for. So we go to our SOHCAHTOA, and just to remind you, SOHCAHTOA, just in case y'all forgot, I should have wrote it earlier. SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and then TOA, tangent, is opposite over adjacent. So in the case of this one, we have an adjacent, we have an hypotenuse, so adjacent and hypotenuse. So that means that we're probably dealing with cosine. So when we write our equation out, it's going to be cosine of 41 degrees is equal to adjacent over hypotenuse. So adjacent is x over hypotenuse, which is 11. So when I solve for x, I'm going to multiply both sides by 11, since x is being divided by 11. We want to do the opposite operation. And that's going to give me my x. So 11 times cosine of 41. And again, remember that set your calculators to degrees. And I get that x is equal to approximately 8.3. And remember, we're rounding to the nearest tenth. So for number 15, x is equal to 8.3. 17, notice on number 17 that my angle is 36. Uh, 10 seems to be across or opposite of 36, so I would say that 10 is opposite. Notice that the x is across from the 90 degree symbol, so I'm going to say that x is my hypotenuse. So if we go back to our SOHCAHTOA, we have opposite and hypotenuse, so that's the sine is opposite over hypotenuse. So in this case, it's going to be sine of 36 is equal to opposite over hypotenuse. In this case, it's going to be x. So sine 36 is equal to 10 over x. So the way to solve this is I'm going to first multiply both sides by x to get rid of that x in the denominator. So I have x times sine of 36 is equal to 10. Then I'm going to divide both sides by sine of 36 so I can isolate the x. And that gives me, grab your handy dandy calculators. Remember to set your calculators to degrees. I get that x is equal to 17.0 or 17. Either one is fine. So this one was a little different from the last one because we have the hypotenuse that we're looking for. We just had to multiply both sides by x and then divide it by the sine of 36. And you got you 17. So I actually like question number 18. And because I like it because they give you two angles and you're like, well, which one do I use? Which one do I use? And it really doesn't matter as long as you set up the correct trigonometric ratio, as long as you use the correct sine or the correct cosine or the correct tangent. So what I'm going to do for 18 is I'm going to do both for both angles. I'm going to do it for both angles. And for both angles, we'll use two different trigonometric ratios. So let's start with 28. So let's say I had angle 28. If you look at 50, 50 is across or opposite of 28, so I'm going to say that 50 is opposite, and x is my hypotenuse, and I'm looking for that, right? So that's the 90 degree symbol, and it's across from that, so I'm going to say that my hypotenuse will be x. So I have an opposite, and I have an hypotenuse, so looking at my SOHCAHTOA, I'm going to say that sine is opposite over hypotenuse, so I think I'm dealing with sine, so it's going to be sine is equal to sine of 28 is equal to opposite, in this case is 50, over hypotenuse. I'm going to multiply both sides by x. I'm going to get that x is times sine of 28 is equal to 50. Then I'm going to divide both sides by sine of 28. And I'm going to get that x is equal to approximately 106.5. And that was using my angle of 28. So it also works with 62. So what does that look like? Let's set that up. So looking at number 18 and looking at the 62, my angle will now be 62. Notice that the 50 is touching 62, so 50 is the leg, the adjacent leg. So I'm going to say that 50 is adjacent. Notice that that's different than when it was 28. And x is still opposite of the 90 degrees symbol, so x is still my hypotenuse. Looking at my SOHCAHTOA, I think that's the one I want to use. Cosine is adjacent over hypotenuse. So cosine of 62 is equal to 50 over x. Multiply both sides by x. That gives me x is times cosine of 62 equals 50. And then x is going to equal 50 over cosine of 62. And I also get that x is equal to 106.5. So, as long as you use the proper trigonometric ratio, for 62 degrees we used cosine, for 28 degrees we use sine, it should get you to the same answer. So we're going to do 2 more, or 3 more, and then we're done. So we're going to do questions 22, 23, and 24. They want me to find the value of x. So looking at this, these are going to be the trigonometric functions when we use the inverse of these. So in this case, my angle is x, and we're going to do everything in relation to that x. 14 is opposite of the 90 degree symbol, so I know that 14 is my hypotenuse, and 5 is across or opposite from angle x, so whoops, it is 5. Okay. Opposite hypotenuse, that tells me from SOHCAHTOA I'm dealing with sine, so it's going to be sine of x is equal to opposite, which is 5, over hypotenuse. Opposite over hypotenuse. But we're trying to find that angle, right? So the way that we deal with that is that we're going to use the inverse. We're going to use the inverse. So the inverse of sine of x is equal to the inverse of 5 over 14. The reason why I'm doing it this way is just to show that that the inverses of sine and sine cancels each other out, and then it leaves me just with x. So x would be equal to the inverse of sine 5 over 14. If you, in your problems, just want to go straight to this part, that's fine. This part is just to show you guys where it came from. So in order to use the inverse feature in your calculator, you want to press the second button, and then that sign button, which is also the inverse. And then you put in the fraction, and I get that x is 20 56.9 degrees. Remember to set your calculators to degrees. There's 3 functions in it. There's degrees, radians, and gradians, or DEG. Radians, RAD. Gradients, GRAD. Make sure that your calculator is set to degrees. Okay, so that was 22. 23, again, we're looking for the angle, so our angle is x. If I look at 23, there is no hypotenuse, so we don't have to worry about that. The leg that's touching x is 5, so that's going to be my adjacent side. And then 8 is a cross or opposite of angle x, so my opposite is going to be 8. So I have adjacent and opposite. That tells me that from SOHCAHTOA it's going to be the TOA, or tangent. So tangent of x is equal to opposite over adjacent, TOA. So opposite over adjacent, so 8 over 5. When I solve, I'm going to inverse tangent both sides. Again, you don't have to write this part if you don't want to. This is just to show you where this is coming from. The inverse tangent and the tangent cancels. What I do on one side, I must do to the other to maintain the equal sign. So x is equal to the inverse tangent of 8/5. So remember second, then inverse tangent. And I get that x is equal to 57.99, and that rounds up to 58.0 degrees. Just a note for your rounding for those who don't remember. If you have a 9/9 and they tell you to round to the nearest tenth, you're going to round that 9 up, right? And it's going to be a 58. But usually most people write it as 58.0 to show that you rounded up from a 9/9. So that's just mathematical food for thought. That was number 23. So we'll do one more. Number 24. Again, we're looking for x. I see that we have an adjacent here to the relation to the x, so that's going to be 9, and 13 is my hypotenuse because it's opposite of the 90-degree symbol. So looking at my SOHCAHTOA, looks like it's the CA, or cosine is adjacent over hypotenuse, so cosine of x is equal to adjacent over hypotenuse. Again, I'm going to inverse cosine both sides. And remember, you don't have to write this part if you don't want to. What I do on one side, I do to the other. So inverse cosine is 9 over 13. So x is equal to the inverse cosine of 9 over 13. And I get that x is equal to approximately 40. Whoa, my markers. It's just as bad as the whiteboard in class. 46.2 degrees. Okay, so that's a couple questions that I did for you guys from lesson 8.3. I'm going to give you guys a worksheet to do, a course worksheet to do for next class. So hopefully this will be beneficial for when you guys do that. And that's going to be a mandatory coursework. It's not optional, so that'll be due. And I'll talk about how you get that to me next time. Enjoy the rest of your day, guys.